All right, so welcome back to this tutorial. So in this tutorial, we're solving question 9 from the tutorial sheet. And question 9 is basically on question 9 is simply on the unit vectors, how to use unit vectors, how to apply them, and also to find it's also the last part of question 9 is talking about parallel vectors. Yeah, so how do you know whether or not the vectors are parallel? Okay, so let us check. Let us check, or let us see how we can solve such questions. Okay, so we begin. So the first question is, find a unit vector that points in the same direction as u. So u has been given as um, u has been given as 2i, then plus 7j, then minus 5k. So now the question is, how do you find the unit vector that is pointing in the direction of how do you find the unit vector that is pointing in the same direction as uh, this vector u? So this is a very simple question. Okay. So this is a very simple question. So what is a unit vector? So a unit vector is simply just a vector that has the magnitude 1. And the way you find the unit vector, if let's say for instance, if you have the vector v, sorry for that. So I wrote u here as 2i plus 7j minus 5k. So if let's say for instance you have a vector v, a unit vector in the direction of v is denoted by v cap, and this is equal to you get the vector v and then divided by its magnitude, meaning you're dividing by the magnitude of v. So now let us find the unit vector in the direction of u. So the unit vector in the direction of u is simply just going to be denoted by v cap, which is equal to the vector itself, which is u. So this is u cap, then the vector itself, which is u, then divided by the magnitude of u. So what this tells us is that what this is telling us is that we have to first find the magnitude of what? We have to first find the magnitude of u. So the magnitude of u is simply just equal to the square root of what we have there. The vector that we have is 2i plus 7j plus rather minus 5k. So we put our 2, we square it, then plus 7, we square it, then we have our negative 5 there. We also do the squaring. So the magnitude of u is therefore going to be equal to the square root of, so 2 squared there will be 4, and then 7 squared there gives us 49, and then negative 5 squared gives us 25. So the magnitude of u there is therefore going to be equal to, so 4 plus 49, that will give us 4 plus 49, that will give us 53. So 53 plus 25, that will give us 78. Yeah, if I've not mistaken in the calculations, then this is the magnitude. So this is what we have gotten. Yeah, so we have 78 as the magnitude, the square root of 78 as the magnitude of this vector. So now to find the unit vector in the direction of u, we divide the vector itself there, which is 2i plus 7j minus 5k. We divide it by its magnitude, which is the square root of 78. So if you want, you can leave it like this. Some markers will recommend that you leave it in this format, which is 2 over the root of 78I plus 7 over the root of 78J minus 5 over the root of 78K. So whether you leave it like this or like that, the answer is still the same. So how do you prove that this is a unit vector? Try to find the magnitude of this vector. And if you find that the magnitude of this vector is 1, then you conclude, or you know to say your answer is correct, because it's only a unit vector that has a magnitude of 1. Okay, so let's move on to the next question. So part B is asking us to find the unit vector in the direction of V. So the vector V has been given to be negative 3J and then minus 11K. And then they've asked us to find the unit vector in the direction of V. So how do you find the unit vector in the direction of V? Remember, we said if you are finding the unit vector, this vector will be denoted by V cap, which is equal to the vector itself, which is V, and then over the magnitude of V. So let us first find the magnitude of V. So the magnitude of V is simply just equal to, the magnitude of V is simply just equal to, we say the square root of negative 3, then we square this and say plus negative 11 squared. So the magnitude of V is therefore going to be equal to, we have the square root of, so negative 3 squared gives us 9. Then we say plus 11 squared gives us 121. So from there, the next thing that you need to do is to add this. So 121 plus 9, the answer gives us, the answer is simply just the root of what? 130. So this root of 130, you can either simplify it further. If you know how to simplify such, you can you can simply simplify this further, or you can just leave it the way it is. There's no problem. Yeah, so the unit vector in the direction of V is therefore going to be V has been given to be negative 3 J minus 11K. And then everything is equal to, sorry, everything will be divided by the square root of what? 130. So V cap is therefore going to be equal to negative 3J over the root of 130. Then we say minus 11K over the root of 130. So this is exactly what you're supposed to find on part B. So let's move on to part C and see what we're supposed to do. So to prove part B, you have to find the magnitude of the final answer that we found. So if you find that the magnitude is 1, then you conclude that your unit vector is, rather, you conclude that the answer that you've gotten is correct. So let's quickly move on to part C. So part C is asking us to find the unit vector in the direction of, sorry, it's asking us to find a vector that points in the same direction as P with magnitude 1 over 2. So we've been asked to find the vector that is pointing in the direction of P, and it has the magnitude of 1 over 2. So now this is very simple. How do you find such a vector? So you find that vector by first finding the unit vector in the direction of P, and then you multiply that unit vector by 1 over 2. So the unit vector in the direction of P is simply just, so we have P. So the unit vector in the direction of P is going to be P over the magnitude of what? P. So first of all, we need to find the magnitude of P. So the magnitude of P is going to be the square root of, we have 2 squared minus, sorry, plus, then we have negative 3 squared plus, then we have 1 squared. So the magnitude of P there is therefore going to be equal to 2 squared, this will give us 4. Negative 3 squared, this is 9. Then we have 1 squared, which is 1. Okay. So having done that, the next thing we're supposed to do is to simplify this expression. So the magnitude of P is therefore going to be the root of, this is 9 plus 4, that's 13 plus 1, 14. Okay. So we can write our unit vector. This will be 2i over the root of 14. We have minus 3 over the root of 14j and plus 1 over the root of 14k. So now to find the vector that points in the same direction as this vector p, rather as this vector p, and it has the magnitude of 1 over 2. How do you find that vector? So we simply just have to multiply, we simply just have to multiply this magnitude to the unit vector. So let us do that. We are going to prove this answer so that we know that what we found is correct. Okay, so the vector, I'm going to say, let this vector be so let this vector, so I'm going to say, let the vector that I'm going to find be, okay, I'm going to say let this vector be equal to v. You can let it be equal to any vector that you want. So v is equal to 1 over 2 times p cap, which is the unit vector in the direction of p. Okay. So now let us find this vector. So our v is therefore going to be half times the unit vector that we have there. So that is what we are supposed to do. So we have to multiply this to find the solution. So this vector will therefore be equal to, when you multiply half times that, the answer will be 1 over the root of 14i. When you multiply half times 3 over the root of 14, the answer is simply just going to be, we have negative 3 over 2 root 14. And we have j there. Then we multiply half times that, we're getting 1 over 2 root 14. Okay. So to prove this answer, if you want to prove that this answer is correct, this is the final answer, by the way, but if you want to prove that this answer is correct, you can try to find the magnitude of this vector. Let us try to do that. We see if it's going to give us 1 over 2 as the answer. So I want to prove to you that this answer that we have found is correct. So this is a very simple topic. Vectors are very simple. It's not something that you even have to waste time or to spend time on if you find a question in an exam or a test. So you just need to walk. I mean, this is just a straight away walkover. In short, this is simple. So let us see what we can do. Let us see our solution. Okay, so let us prove this. So let's try to find the magnitude of this vector. So the magnitude of this vector will be 1 over the root of 14 squared minus 3 over the root of, 2 root 14. Sorry, this is plus squared, and then we have plus 1 over 2 root 14 squared. So this is what we have. And then from there, we also need to, we just need to simplify this. Yeah, so when you simplify that, you are getting the root of this part here. The square root of this part is simply just 1 over 14. Then here, when you square, you're going to get positive 9 over 28. So 9 over 28 is simply just 3 into 9. That is not really 28. This should be 9 over 14 times 4. That should be 56. So we have 9 over 56. So we have 9 over 56. Then we have plus 1 over 56. Yeah, so this is what we have. Yeah, so even this one can be changed. If you want to simplify your work, you can change this part to 4 over what? 4 over 56. If you want to make your work easier, it will still give you 1 over 14. So when you add everything there, you are getting something like the square root of 9 plus 4 plus 4 plus 9 plus 1, that's 14, everything over 56. So 14 over 56, the answer will give us what? We're trying to prove if the answer is going to give us 1 over 2. Let's see if the answer that we're going to get is 1 over 2. So the square root of this, or before we find the square root, we can reduce this. 14 into 14, 1. 14 into 56, 4. So the square root of 1 over 4 is simply just 1 over 2. We see here that the vector that we found has the magnitude 1 over 2, which proves our answer to be correct. Okay, so this is how you prove your answers, or this is how you know whether what you have found is correct or wrong. Okay, so let's quickly move on to the last part of the question. Okay, so we proceed with the last question. So the last question says, determine whether this vector u and w are parallel. So when vector u is parallel to vector v, what this means is that, or this implies that when these two vectors are parallel, it means that okay, I've seen something. The second part, which is part B, it was saying we find the vector that is in the opposite direction. So in the vector, I mean, in the unit vector that we found on part B, we are supposed to include a negative in front of the vector. So I've just forgotten the vector that we found. But if, let's say, for instance, the vector that we found was 2i plus 3j plus 7k. If this is the vector that we found, the vector that is in the opposite direction to this is simply just found by multiplying the whole vector by negative. So the answer that we got, you simply just have to make sure that where there was negative, put plus. So in short, it was supposed to be positive 3 over the root of 130 plus 11 over the root of 130. That was the unit vector in the opposite direction to that vector. All right, so let us quickly find or determine whether u is parallel to w. So for two parallel vectors, you need to know to say, for two parallel vectors, you need to know to say u is equal to what? K v. If vector u is parallel to v, it means that the only difference between u and v is the scalar there. So what this means is that we can, what this is telling us is that we can say vector u, I'm going to put vector u here, which is I, 0, j, and negative 4, k. So let me not put the I, j, and k symbols. Let me just write the numbers. So the numbers that we have, so this side we have w. So the numbers that we have are 1, we have 0 and negative 4. So we're trying to find the values of k. So if the values of k are all going to be the same, then we conclude that the vector v is parallel to w. So we have k there, and then we have 9, we have 3, we have 1. So I've just written these two vectors in this matrix format. So I'm going to say 1 is equal to k times 9, which is 9k. So meaning the first value of k here is 1 over 9. Then I'm also going to say 0 is equal to 3 times k, which is 3k. So the second value of k is 0. So since the first two values of k are different, this tells us to say the two vectors are not parallel. Yeah, so if you